Hi friends, very good morning. Welcome to Anu Academy. Very good morning, friends. Let us start today's class. I think all of you are preparing for your assistant engineering exam. You're having your exam on May month. Okay, so countdown has started. So all of you prepare well for your exam. If you are having any doubts, please post in the comments box. I will give you a reply. So let us start today's class. Today's class in our channel, we are going to discuss welded joints, columns and struts. Okay. So let us start today's class. Material is ready. We will start discussing. Right. Material is in front of you. Okay. We will start discussing. First, we'll start with welded joints. In a fusion welding process, only heat is used, only pressure is used, combination of heat and pressure is used, none of these. Okay, so in a fusion welding process, the correct option is only heat is used. Okay, next, the electric arc welding is a type of dash welding. The electric arc welding is a type of fusion welding. Okay, the principle of applying heat and pressure is widely used in spot welding, seam welding, projection welding, all of these. So the principle of applying heat and pressure is widely used in all of these, that is spot welding, seam welding, projection welding. In transverse fillet welded joint, the size of weld is equal to 0.5 into throat of weld, next throat of weld, next root 2 into throat of weld and 2 into throat of weld. So in transverse fillet welded joint, the size of weld is equal to root 2 into throat of weld. Okay, the transverse fillet welded joints are designed for tensile strength, compressive strength, bending strength, shear strength. The transverse fillet welded joints are designed for tensile strength. The parallel fillet welded joint is designed for tensile strength, compressive strength, bending strength, shear strength. So the parallel fillet welded joint is designed for shear strength. The size of the weld in butt welded joint is equal to 0.5 into throat of weld, root 2 into throat of weld, 2 into throat of weld. So the size of the weld in butt welded joint is equal to throat of weld. A double fillet welded joint with parallel fillet weld of uh, length L and length L and leg S is subjected uh, to a tensile force P, assuming uniform stress distribution. The shear stress in the weld is given by root 2 into P by S into L, P by 2 S into L, P by root 2 S into L, 2P by S into L. So a double fillet welded joint with parallel fillet weld of length LS and leg S is subjected to a tensile force P, assuming uniform stress distribution. The assuming uniform stress distribution, the shear stress in the weld is given by P by root 2 S into L. So this is the correct option, P by root 2 S into L. Okay, next, when a circular rod welded to a right plate by a circular fillet weld is subjected to a twisting moment T, then the maximum shear stress is given by 2.83 T into T by pi S d square. Next, 4.242 into T by pi S d square. Next, 5.66 into T by phi S d square. None of these. So the answer is 2.83 into T by pi S d square. Okay. Last one. For a parallel load on a fillet weld of equal legs, the plane of maximum shear occurs at 22.5 degrees, 30 degrees, 45 degrees, 60 degrees. So it is 45 degrees because it is a parallel load on a fillet weld of equal legs. The plane of maximum shear occur. The plane of maximum shear occurs at 45 degrees. Okay. Now we'll start discussing columns and struts. Okay, columns and struts. A machine part is designed as a strut when it is subjected to an axial tensile force, an axial compressive force, and a tangential force, any one of these. So it is an axial compressive force. Slenderness ratio is the ratio of maximum size of a column to minimum size of column, width of column to depth of column, effective length of column to least radius of gyration of the column, and effective length of column to width of column. So slenderness ratio is the ratio of effective length of column to least radius of gyration of the column. Next, a connecting rod is designed. A connecting rod is designed as a column, long column, short column, strut, any of these. So a connecting rod is designed as a strut. Which of the following formula is used in designing a connecting rod? Is used in designing a connecting rod. So Euler's formula, Rankine's formula, Johnson's straight line formula, Johnson's parabolic formula. So which of the following formula is used in designing a connecting rod is Rankine's formula. A connecting rod subjected to an axial load may buckle with the x-axis at neutral axis, y-axis as neutral axis, x-axis or y-axis as neutral axis, d is z-axis. So here a connecting rod subjected to an axial load may buckle with, the answer is x-axis or y-axis as neutral axis. Okay. In designing a connecting rod, it is considered like dash for or buckling about x-axis. Okay. So here both ends hinged, both ends fixed, one end fixed and the other end hinged, one end fixed and the other end free. So in designing a connecting rod, it is connected like dash for buckling about x-axis, both ends hinged. So the option is both ends hinged. Okay. Next, a connecting rod should be strong in buckling about x-axis, strong in buckling about y-axis, equally strong in buckling about x-axis and y-axis, any one of the above. So a connecting rod should be equally strong in buckling about x-axis and y-axis. The buckling will occur about y-axis if ixx equal to iyy, ixx equal to 4iyy, ixx greater than 4iyy, ixx less than 4iyy. Okay, so the correct option is the buckling will occur about y-axis if ixx is greater than 4iyy. Next, the connecting rod will be equally strong if buckling about x-axis and y-axis if ixx equal to iyy, ixx equal to 2iyy, ixx equal to 3iyy, ixx equal to 4iyy. So the correct option is ixx is equal to 4iyy. Okay. Last one, the most suitable section for the connecting rod is L section, T section, I section, C section. So it is I section. So that's all, friends, for today's class. I think all of you, today's class will be helpful for all of you, those who are preparing for AE exam as well as AEE conducted by APPSC as well as Telangana State Public Service Commission. So each and every class I am saying the same thing. Give equal importance for both the papers. One is the mechanical engineering, other is the general studies. Okay. So if you are not subscribed our channel, please subscribe our channel. Please like and share our channel. Thank you very much. Thank you for watching.